All right, so again, our focus is change. Okay, our focus is change. What has changed? And that's what we keep an eye on, right? So we've been given this function, right? This function we can also say that it's y. Okay, so now what will be the derivative here? We can say that it's going to be that, or it's going to be represented as change in y over the change in x. And what is it actually? It's the limit when the change is approaching zero. Okay, and where is this change? It's going to be in this function. We take away this function, right? And then we divide by the change. So that's what we do. And remember, we said that we have to remember everything we've done so far. Otherwise, it becomes very difficult to master, right? So you have to remember what we've done. So we did functions. If you haven't gone through these, just check the playlist. There's somewhere where we've done functions. If we have fx, right? And fx is like this. So if we have a change here, this fx is going to be what? It's going to be x plus 1 squared. Not x squared plus 1. That's something else. It's going to induce that value that you've changed into the previous variable there. We're not adding this one on the side. This is what is going to happen here. So you'll see that I'm going to leave this one out for now, but we'll reintroduce it at the right time. Okay, so now what we'll do is we are going to be very careful and introduce these changes into this. Okay, let's remember there's limit here, there's h is equal to 0, but we're just not putting it there to reduce the clutter. Right, so we're going to say 5, then we're going to put the new variable there. We maintain the power, right? Then we go to the next part. So we're inducing these or including these or introducing these in the main function, right? So I'll make sure that I close this out, keep it safe from any other change. And then here I'm going to say 5x squared minus 3x plus 7, like that. Okay, now we said that we're dividing by h. Now I won't put it under h, under this, but I'll introduce new brackets and then put division by h here, because we need space and it won't be enough if I keep putting a big line divided by h. All right, so this is the most important step when you're dealing with limit definitions. So we're going to do our expansion and we include our brackets. So our expansion here is going to be 5. Remember, we also did these, quite a bit of this. So it's x squared plus 2xh plus h squared. Remember, everything comes together every time. You have to really be good at remembering what's been done. Okay, so 3x, then here we're going to have 3h, then plus 7. Nothing must be left behind. The moment you do, the whole integrity is gone, right? Then here we're going to remove this first bracket. Then we're going to say x squared minus, then this one will be plus 3x. This one will be what? This one will be minus 7. And then the main bracket that's helping us with division comes back. So it's this one here and that one. They're helping us to divide this whole statement here by h, right? We could put it under here, but space won't be enough. Right, so here now, what we do is we do our expansions, the next series of expansions. So we're going to have squared. I bring my main bracket here, plus 10xh. Now we're introducing the 5, okay? Then plus 5h squared. What else? We are going to have 3x. Remember, the 5 is not reaching these. It's just ending at h squared. Then we maintain these, plus 7. Now remember, this is already expanded. We just copy it exactly the way it is. That is why it's very important to do it correctly the first time. Okay, and then we divide by h. We look for like terms and see their behavior. This is the same as that one, but they're positive. They are same but different sides. So this and that can actually cancel out. We look at the next term. I always look at the terms from this side. So this, I go and find its like term and do whatever is required. Here, I look for the like term. It's not there. So I proceed to the next one. Here, I look for the like term. I don't see it. I go to this one, look for its like term. I find it. It's the same, different signs. They cancel out. I go to the next one. Nothing repeats. So I maintain it. This one and that one cancel out. Which means that we can actually take this one, 10xh, right? Then plus 5h squared, then minus 3h, right? And then we can now divide by h. And then we can reintroduce at this point our limit definition. Right? This is our derivative. But now, let's remember, if we went in here blindly and introduced our h to finalize this, look at what will happen. Here it will be 0, there it will be 0, there it will be 0, and there it will be 0, meaning that we're going to get this form. So do we proceed at this point? No. Now we have to look at how do we avoid this. Usually it's the one at the bottom. So what do? We're going to repeat this. H is approaching 0, right? Then we're going to factorize h. This is going to be our trick. So you have to know these tricks. Then we're going to say plus 5h, right? And then we're going to have minus 3 because we've removed the h outside. And then here we're going to say that. So this one and that one cancel out. And so our limit definition is going to be h 0 like that. Right? Once we have this, 10x plus 5h minus 3. Meaning that now if we introduce 0 here, it won't give us 0 over 0, right? So what does it mean? It means that we have here, now we can get our h and put it into where we have h values. So you can see we have h here. So it means that our function, therefore, this one gives us 0. So we can say that our function, okay, the first derivative of that function is going to be 10x minus 3. Why? Because this becomes 0. So we can also represent this as dy over dx is equal to 10x minus 3. All right. So this is the derivative of that function here. Okay, this one here. All right.